Welcome to Study Loop.
So here we have a system that is going from the point A to the point B, from one state, state A, to the state B, and we have the diagram of this process on the problem given figure. So the work done for a C gas system in relationship with pressure and volume is usually given as that work equals pressure times the change in volume. This is derived from the standard definition of work, that is force times the change in the change or the path across which the force is exerted continually. So we know that the force is pressure times area times the path taken, and if the path is linear and the force is constant, then this obviously turns into pressure times volume, since area times some length gives volume. And this is in most cases like this. If a pressure is a function of volume and it's not really straightforward like this, then the other law, the more generalized pressure expression, is an integral from first your initial volume to the final volume of the pressure function. And this is not going to be just delta V, is going to be a differential, infinitesimally small volume, so it is going to be dV. And for example, on the graph, this would look like this. We have pressure P, we have volume, and we have some change like this, and the work done will be this area below the curve, so this area right here. This is generally true for any kind of function. When we integrate function, like in this case P over V, any function over its argument, the integral will be equal to the area below the curve for a monovariable function. For the function, it has only one variable. Therefore, in such cases, the integral is equal to the area below the curve on the graph. So in this case, that is also true. And when we observe the given figure, we can see that the path 1 has the largest area under the curve. Therefore, the final answer is that path 1. This is the answer for the part A of the problem, that this is the path along which the greatest work is being done. And for the part B of the problem, we are asked for the relationship of the heat and the rest of the system. So we have to apply the first law of thermodynamics. This is going to be that the heat flow, Q, is going to be equal to the change in internal energy of the system plus the work done. So this simply means if the energy is not given in or out due to some work being done, then the energy is being stored in the system, and this is the internal energy here. And in this case, we are given this. We have two internal energies. We have internal energy at the point A and the internal energy at the point B that is different from the point A. So, but we know that the point B has larger internal energy, or we know that UB is larger than UA. Therefore, we can say that Q is equal the difference for the whole process. It will be the difference UB minus UA, the difference between internal energies, since this will dictate the change in internal energy, plus the work done. And since this is going to be positive because of this condition, and we know that the work done is also positive from the figure that is given in the problem, we can conclude that Q is going to be larger than 0, meaning it will be a positive value. This means since the heat value is positive, then the heat is being absorbed, meaning that the work done is done on the system and it is done to increase the internal energy of the system, and the total heat is positive and the heat is being absorbed. So this means the heat is being absorbed. And by this we have finished the part B of this problem. And the whole solution is now complete. I hope you found this helpful, and I hope to see you in another lesson.